What do we truly know about life beyond Earth? We have scanned the stars for over half a century. We have found thousands of new worlds orbiting distant suns. We have detected strange, powerful signals that flash once from the darkness and then disappear forever. We have found impossible chemicals in the atmospheres of our nearest neighbors. The clues are scattered, buried in old data from forgotten missions and in the cutting edge of new discoveries. The evidence is growing that something is out there, but the greatest question remains. Could the first definitive proof of life beyond our world have been found decades ago and then been completely and utterly missed? Before we journey further, feel free to leave a comment with from what location you're watching this and what time it is there. Now, settle in as our exploration truly begins. In the summer of 1976, two remarkable machines, the pinnacles of human engineering, successfully touched down on the cold, red, dusty plains of Mars. NASA's two Viking landers, miracles of engineering for their time, were not just geological probes. They were the first, and to this day, the only spacecraft ever sent to another planet with the explicit primary mission to search for active, living organisms. On board each lander was a miniature automated biological laboratory, designed to scoop up the alien soil and feed it to see if anything would respond. And one of these experiments, an elegant and clever design, sent back a result that has been the subject of intense and heated debate ever since. A result that, to this day, could be interpreted as the first discovery of extraterrestrial life. The experiment was known as the labeled release. Its logic was straightforward. If life, specifically microbial life, existed in the Martian soil, it would likely be dormant, waiting for the rare presence of water and nutrients. The lander's robotic arm scooped up a small sample of the reddish soil and placed it in a tiny test chamber. It then introduced a drop of a nutrient solution, a sort of chicken soup for microbes, which was tagged with radioactive carbon-14. The idea was that if any microorganisms were present, they would consume the nutrients, and as part of their metabolism release a gas that contained the radioactive carbon. The lander would then listen with its sensors for this radioactive exhalation, the telltale breath of Martian life. When the nutrient solution was added to the soil, something extraordinary happened. The sensors immediately detected a sharp spike in radioactive gas. The soil began to breathe. The result was not ambiguous. It was a clear, strong, and positive signal, exactly what the experiment's designer, the scientist Gilbert Levin, had predicted would happen in the presence of life. A second, control experiment was then performed. A duplicate soil sample was heated to a sterilizing temperature, and then given the nutrient solution. This time there was no reaction. The breathing stopped. This seemed to confirm it. The agent in the soil was heat sensitive, just like living organisms. For a brief, electrifying moment, it seemed as if humanity had discovered life on Mars. But the celebration was short-lived. Other experiments aboard the Viking landers, designed to search for the building blocks of life, organic molecules, in the Martian soil, came back completely empty. This created a profound contradiction. The labeled release experiment indicated active metabolism, but the other instruments could find no sign of the molecules that should be the basis of that life. Faced with this conflicting data, NASA made a historic and cautious decision. They concluded that the breathing must be the result of some strange, unknown, and exotic chemical reaction in the Martian soil, not biology. The positive result was officially declared a false positive. For the majority of the scientific world, the case was closed. Mars was a dead planet. Yet for the last 5 decades, a compelling counter-narrative has persisted, championed by Gilbert Levin himself and a growing number of other scientists. They argue that the other Viking experiments were simply not sensitive enough, They point out that the instruments were thousands of times less capable of detecting organic molecules than modern technology. Furthermore, subsequent missions to Mars decades later made a crucial discovery that reframes the entire Viking story. In 2008, NASA's Phoenix lander discovered that Martian soil is rich in a class of reactive chlorine-based chemicals called perchlorates. When heated, these chemicals can violently destroy organic molecules. As it turns out, the Viking experiment that searched for organics did so by heating the soil to test it. It is now considered highly plausible that the Viking lander found organic molecules, the very building blocks of life, and then inadvertently incinerated them with its own experiment. In this light, the labeled release experiment, which did not heat the soil, may have been the only one that worked correctly. The possibility remains, haunting the history of space exploration, that we discovered microbial life on Mars in 1976, and then, because of a flaw in our other instruments, we convinced ourselves that we had not. The strange, unresolved, and deeply unsettling mystery of the Viking landers remains one of the most significant alien facts we possess. It is a story of a profound question that received a clear, positive answer, which we then, for a variety of logical but perhaps incorrect reasons, chose to disbelieve. It has reshaped our entire approach to searching for life, teaching us that the signs may be subtle, and that our own assumptions can be the greatest barrier to discovery. But just 1 year after this profound and unsettling mystery was buried in the red soil of Mars, our instruments picked up another anomaly, this time from the unimaginable depths of interstellar space. It was not a chemical signature. It was a sound, a single powerful and utterly inexplicable transmission that lasted for just 72 seconds, and has never, ever been heard again. A signal so strange, so perfectly artificial in its characteristics, that the astronomer who discovered it could only write one single astonished word in the margins of the data printout. Wow. The silent, unanswered question left by the Viking landers on the plains of Mars would not be the last time that world would offer us a tantalizing and deeply ambiguous clue. The search for evidence would soon move from the robotic exploration of another world to the meticulous microscopic examination of a visitor that had come to us. This next chapter in our story is not about a signal or a chemical reaction, but about a physical object, a 4-pound piece of another planet that journeyed across millions of miles of empty space for 16 million years. A rock that was blasted from the surface of Mars by a cataclysmic asteroid impact, and which ended its long, silent pilgrimage in the one place on Earth pristine enough to preserve it: the frozen, sterile ice fields of Antarctica. Discovered in 1984, the meteorite known as Allen Hills 84001 was at first just another curious rock. But a decade later, when scientists analyzed its interior, they found something so extraordinary that it would lead to a televised address from the President of the United States, and briefly convince the entire world that we had finally found definitive proof of life beyond Earth. In August of 1996, NASA held a press conference that would become a landmark moment in the history of science. A team of researchers, after 2 years of secret and intensive study, announced to the world that they had discovered what they believed to be the fossilized remains of ancient microbial life, entombed deep within the Martian meteorite. The evidence they presented was not a single unambiguous discovery, but a convergence of 4 separate tantalizing clues, all found within the rock's ancient cracks and fissures. First, they had found complex organic molecules, polycyclic aromatic hydrocarbons, or PAHs, the very same kind of soot-like compounds that are often the byproducts of decaying biological matter here on Earth. Second, they had found microscopic crystals of the mineral magnetite, of a specific size and purity that, on our planet, is almost exclusively produced by certain types of bacteria to help them orient themselves with a magnetic field. Third, They found small circular carbonate globules that appeared to have been formed in liquid water, and in a way that was consistent with microbial activity. And fourth, and most famously of all, when they used powerful electron microscopes to look deep within these carbonate globules, they found them tiny, segmented, worm-like shapes that were, to all appearances, the fossilized bodies of nanobacteria, alien microbes 1,000 times smaller than a grain of sand, the apparent remnants of a simple, ancient Martian ecosystem. For a brief, electrifying period, it seemed as if the question had been answered. But science is a rigorous and skeptical process, and this extraordinary claim was immediately met with an onslaught of equally extraordinary scrutiny. One by one, alternative, non-biological explanations were proposed for each of the four clues. The organic molecules, critics argued, could be the result of contamination from the Antarctic ice after the meteorite landed, or they could have been formed by simple inorganic chemical reactions on Mars. The unique magnetite crystals, while often made by bacteria, could also, under very specific conditions of high temperature and pressure, be formed by the shock of the very impact that blasted the rock off the Martian surface in the first place. The carbonate globules, similarly, could have been formed in hot volcanically active water with no need for any biological assistance. And the most compelling evidence, the tiny worm-like fossils themselves, could simply be unusually shaped but entirely natural mineral formations that just happened to look like bacteria. The debate raged for years, with teams of scientists around the world publishing papers that both supported and refuted the original claim. The scientific consensus today has largely shifted away from the initial, exciting conclusion that ALH 84001 contains definitive proof of Martian life, the possibility of contamination, and the existence of plausible non-biological explanations for the evidence have made the claim too uncertain to be considered proven. The structures that look like fossilized bacteria are, to most scientists now, simply too small to have been viable, living organisms as we understand them. Yet the mystery has never been completely and utterly put to rest. The original team of scientists, to this day, maintains that the convergence of all four lines of evidence, all found together in the same microscopic location within the rock, is too powerful to be a mere coincidence. They argue that while any single clue could be explained away, the presence of all four at once points strongly toward a biological origin. The story of the Martian meteorite has therefore become a profound lesson in the difficulty of searching for life. It has taught us that even with a physical sample in our most advanced laboratories, the line between a living process and a complex geological one can be almost impossibly blurry. The true and lasting legacy of this incredible discovery, however, is not in the answer it failed to provide, but in the new questions it forced us to ask, and the new field of science it helped to create. The intense debate surrounding the meteorite essentially gave birth to the modern science of astrobiology, a discipline that brings together geologists, chemists, biologists, and astronomers to create rigorous standards for what would constitute definitive evidence for extraterrestrial life. The controversy forced us to think deeply about how to protect future samples from contamination, and it directly led to the development of the advanced, life-seeking instruments that are now on board rovers like Perseverance. The strange rock from Allen Hills was a scientific catalyst, a Rosetta Stone for an alien world that we're still learning how to read. It remains a deeply ambiguous and tantalizing clue, a hint that Mars was once a warmer, wetter, and perhaps even a living world. The unresolved story of the Martian meteorite is a perfect illustration of the state of our search. We are haunted by ghosts. The ghost of a metabolic reaction in the Martian soil, the ghost of a powerful radio signal from a distant star, and the ghost of a fossil in a rock from another world. All of these clues are powerful, suggestive, and deeply mysterious, yet none of them provide the final, unambiguous proof that we seek. This has led some thinkers to step back from the search for individual clues and instead to try and calculate the odds, to create a formula not of chemistry or biology, but of pure probability, designed to estimate the number of intelligent, communicating civilizations that might exist in our galaxy, an equation that, when updated with the incredible data from our modern telescopes, produces a truly staggering and deeply hopeful result, and presents us with an even deeper mystery. Our search for life beyond Earth has, for all of our history, been a search for ourselves. We look for planets in the habitable zone, which we define by the presence of liquid water, the one solvent we know is essential for life. We scan for atmospheres rich in oxygen, the gas we breathe, and we analyze the chemistry of distant worlds for the presence of complex organic molecules, the carbon-based compounds that form the bedrock of every living thing on our own planet. This is a logical, but perhaps profoundly limited approach. It is an assumption born of a deep and unconscious bias, a prejudice that some scientists have given a name: carbon chauvinism. It is the belief that because life here is built from carbon and water, then life everywhere must be the same. But the universe is a far more creative and versatile chemist than we are, and to truly search for alien life, we must first open our minds to the possibility that it could be built from an entirely different blueprint. The most famous and scientifically plausible alternative to our own carbon-based biology is a form of life built upon the element silicon. Looking at the periodic table, carbon and silicon are immediate neighbors, existing in the same chemical group. This means they share a crucial property. They can each form stable bonds with up to 4 other atoms, allowing them to create the long, complex molecular chains, the polymers that are necessary for life as we know it. Here on Earth, carbon has won the evolutionary race. But on another world, a world with a different chemical environment, silicon might be the star of the show. A silicon-based life form would be a vision of a truly alien existence. It would likely arise not in water but in a much colder solvent, perhaps the frigid liquid methane or ethane seas that are thought to exist on moons like Titan. Its biochemistry would be incredibly slow, its metabolism unfolding not over seconds and minutes but over years, or even centuries. It would not be soft, pliable, and organic like us. It would likely be crystalline, its very structure more akin to a living rock or a slowly growing crystal. A silicon-based being would experience time and the universe in a way we can barely comprehend. Its thoughts, if they could be called that, might be the slow, patient shifting of crystalline structures, a form of geological consciousness. It would be a life form that is patient, that is durable, and that is fundamentally in tune with the long, slow, and epic timescales of the cosmos itself. Such a creature would see the frantic, rapid life of a carbon-based being like a human as a brief, meaningless flash of light. We would be ephemeral, like mayflies, to a being whose every breath might take a decade. The search for such life would be almost impossible for us. We look for the rapid chemical changes of metabolism, for the heat and the motion of life as we know it. A silicon-based life form would be so slow, so quiet, and so geologically stable that we might land on a world teeming with it, and mistake it for simple, inert rock. And silicon is only the beginning of the possibilities. Some astrobiologists have speculated that on even colder worlds, in oceans of liquid ammonia, the elements of nitrogen and phosphorus could combine to form the complex backbones of an entirely different kind of life. Others have looked to the crushing, high-pressure atmospheres of gas giants like Jupiter and imagined life not on a surface but in the clouds. Vast floating atmospheric creatures like living blimps or biological hot air balloons, feeding on the chemical energy of the storms that surround them, a concept first seriously proposed by Carl Sagan. The most extreme theories speculate about life that is not even based on chemistry at all. In the searingly hot corona of a star, could self-organizing complex patterns in plasma held together by magnetic fields constitute a form of living plasmatic being? Or within the crystalline core of a neutron star, could the crushed exotic matter form a kind of nuclear life, living a billion times faster than we do? These ideas stretch the definition of life to its absolute limits, but they force us to confront a profound and humbling truth. The universe may be filled with life that we are simply not equipped to recognize, because our very definition of life is too parochial, too limited, too hopelessly tied to the single lonely example of it that we have found so far. Our search for life has been a search for worlds like our own, a quest to find water, oxygen, and carbon. But if life can be built from silicon and thrive in oceans of liquid methane, if it can be a slow, thinking crystal or a vast, floating atmospheric cloud, then we have been looking at the universe with profound blinders on. The cosmos may be teeming with living things that we are simply not equipped to recognize or to understand. But what if the fundamental difference between us and them is not just in our chemistry? What if it is in our perception of reality itself? What if alien life exists, but experiences the universe through senses so different from our own that communication, or even mutual recognition, would be impossible? We must now consider the alien mind and the strange and wonderful senses it might have evolved to perceive a universe that is almost entirely invisible to us. Our search for life in the cosmos has, for all of our science and imagination, been profoundly limited by a single, inescapable fact. We are searching for a reflection of ourselves. We have opened our minds to the possibility that life could be built from a different chemical blueprint, that a slow crystalline being of silicon could exist in a frigid methane sea. But even this is a guess based on the familiar rules of chemistry. The true gulf between us and the alien may not be in the materials we are made from, but in the very reality we perceive. Every living thing on Earth is trapped within the confines of its own sensory bubble, its umwelt. We experience the universe not as it truly is, but through the narrow, filtered lens of the senses that evolution has granted us for the sole purpose of surviving on this one specific world. We see a sliver of the electromagnetic spectrum we call visible light, while the vast oceans of radio waves, infrared, and gamma rays pass through us completely unnoticed. We hear a tiny range of sonic frequencies, while the subsonic rumbles of the earth and the ultrasonic cries of bats are a silence to us. Our senses do not show us the universe. They show us a carefully curated, heavily edited, and user-friendly interface for the universe. A biological dashboard designed to help us find food, avoid predators, and reproduce. The crazy alien fact we must now confront is that life on other worlds will have evolved a completely different dashboard, a set of senses tuned to the unique challenges of their own home, and in doing so they will inhabit a reality that is completely and perhaps incomprehensibly alien to our own. To truly contemplate the alien, we must therefore attempt the impossible. We must try to imagine perceiving the universe through senses we do not possess, on a world that orbits a dim red dwarf star, a world bathed in eternal dusky twilight. Vision as we know it might be useless. Life here might evolve a form of hyper-advanced echolocation, painting a picture of its world in 3 dimensions with sound. We can imagine a creature that does not see, but feels the shape of the landscape for miles in every direction, that perceives the texture of a rock, the density of a forest of crystalline flora, and the internal structure of its prey, all through a constant complex symphony of clicks and echoes. It would not know the color red, but it might perceive the subtle difference in the sonic reflection between living tissue and dead matter. Its entire reality would be a rich tapestry of textures, densities, and vibrations. A world of pure physical form, completely devoid of the light and color that dominates our own. On a world with a powerful magnetic field and a thick, conductive atmosphere, life might evolve electroreception as its primary sense. Like the sharks in our own oceans that can detect the faint electric fields of their prey's beating hearts, an alien species could navigate, hunt, and communicate through a complex, three-dimensional, sixth sense for electricity. It might perceive other living things as glowing, shifting electrical fields. It could communicate not with sound, but by modulating its own bioelectric field, a silent, instantaneous conversation of pure energy. Its art might not be painting or music, but the creation of intricate, beautiful, and emotionally resonant electrical sculptures in the air around it. These possibilities, while strange, are still extensions of senses we can find in rudimentary form here on Earth. But the universe is not limited by our planet's evolutionary history. What if a truly alien intelligence evolved to perceive the most fundamental forces of the cosmos directly? What would it be like to possess a sense for gravity, not as a simple feeling of being pulled down, but as a direct perception of the curvature of space-time itself? A creature with this sense could see the mass of an object. It could perceive the invisible gravitational well of its home planet, the subtle, complex dance of its moons, and the gentle, warping presence of its distant star, all as a tangible, visible landscape of dips and curves in the fabric of reality. It could detect a hidden cave deep underground or a dense deposit of metal with the same ease that we see a mountain on the horizon. It would navigate its world not by light, but by following the geodesic contours of space-time. Its movements, a perfect, effortless dance with the deepest law of the universe. Or what of time? We experience time as a relentless, linear flow, a constant movement from a fixed past through a fleeting present and into an unknown future. This perception is so fundamental to our consciousness that we cannot imagine any other way of being. But what if a species evolved to perceive time differently? What if for them, all of time, their entire lifespan, was perceived as a single, holistic, coexisting now? A being with this sense would not have memories of the past or hopes for the future. It would simply experience its entire existence, from its birth to its death, as a single, complete, and unchanging object, a four-dimensional pattern in space-time. Such a being would be, in a sense, immortal and omniscient, at least in regard to its own life, but it would also be a prisoner of its own fate, with no free will, and no possibility of surprise. The existence of such profoundly different sensory realities presents us with a new and perhaps the most powerful solution to the great silence of the Fermi paradox. For decades, we have been scanning the skies with our radio telescopes, listening for a message that is encoded in a way that we can understand. We have been looking for intelligence that thinks and communicates in a way that is at least somewhat analogous to our own. But what if the galaxy is in fact teeming with intelligent, conscious, and communicative life? But we are all, each and every one of us, locked within the impenetrable prison of our own unique sensory dashboards. What if the universe is a cacophony of voices, a symphony of countless intelligent species, all shouting, singing, and communicating with all their might? But we cannot hear them because they are not communicating with radio. They are communicating with modulated gravitational waves. They are communicating with intricate shared patterns of quantum entanglement. They are communicating through a medium that we do not even possess the senses to detect, or the scientific framework to even imagine. The great silence may not be the sound of an empty cosmos. It may be the sound of a million different species, all experiencing a custom-built unique reality, and all of them completely and forever invisible to one another. This possibility, that the universe is not empty, but is instead populated by countless mutually imperceptible realities, is one of the most profound and mind-bending, crazy alien facts of all. It suggests that our search for life is not just a search for other beings, but a search for the limits of our own perception. It reframes the Fermi paradox, not as a question of where is everybody, but as a question of what is everything we are missing. The clues to alien life may not be hidden in the soil of Mars or in a strange radio signal. The clues may be all around us, all the time, in the form of gravitational waves, quantum fluctuations, and other fundamental aspects of the universe that our bodies and our instruments have not yet learned how to read. This leads us to an even more humbling and speculative question. If alien life could be so different, not just in its chemistry, not just in its body, but in its very mind and its perception of reality, then what does this say about the civilizations they might build? How would a species that perceives time as a single, holistic block build a society? What kind of technology would be created by a being that can see the raw geometry of gravity? Our search must now move from the alien individual and the senses it might possess to the alien collective and the truly mind-bending and perhaps terrifying forms that an extraterrestrial civilization might take. The staggering possibility of truly alien senses reveals a profound truth. The universe may not just be populated by different biologies, but by entirely different and perhaps mutually imperceptible realities. The great silence we observe in the cosmos might be the sound of 1,000,000 different species, all experiencing a universe that is custom built for their unique perceptions, and forever invisible to everyone else. This leads us to an even more humbling and complex question. If an alien intelligence could be so different, not just in its body, but in the very fabric of its mind, what does this say about the societies and the civilizations they might build? How would a species that perceives time as a single holistic block ever develop a concept of history or progress? What kind of technology would be created by a being that can see the raw geometry of gravity itself? The sheer variety of possible minds implies a variety of possible civilizations so vast it dwarfs our own human experience. To even begin to think about this problem, we need a new framework, a way to classify civilizations not by their biology or their culture, which we can never know, but by a metric that is universal, objective, and physical. In 1964, the brilliant Soviet astronomer Nikolai Kardashev proposed such a framework. He suggested that the single most important and defining characteristic of any civilization is its ability to harness energy. A civilization's technological level, he argued, could be measured directly by the scale of its energy consumption. This simple, elegant idea created what is now known as the Kardashev scale, a cosmic ladder of technological advancement. At the first rung of this ladder is a Type 1 civilization. This is a society that has achieved complete mastery over all the energy resources of its home planet. A Type 1 civilization would be able to harness the full power of its parent star's light that falls on their world. They could control the weather, prevent hurricanes, and redirect storms. They could eliminate the threat of earthquakes and volcanoes by tapping directly into the geothermal energy of their planet's molten core. They would have achieved a perfect, sustainable, and global energy economy. By this measure, humanity is not yet a Type 1 civilization. We are a noisy, inefficient, and adolescent society, still largely dependent on the fossilized remains of ancient life. On the Kardashev scale, our current civilization ranks as a Type 0.7. We have not yet even mastered our own cradle. The next step up the ladder is a leap of almost unimaginable proportions. A Type 2 civilization is a society that has graduated from its home planet and can harness the entire energy output of its parent star. To do this, such a civilization would likely need to construct one of the most famous and awe-inspiring concepts in all of speculative science, a Dyson sphere, or more plausibly, a Dyson swarm. This would not be a solid, rigid shell around a star. It would be a vast, orbiting swarm of countless independent habitats, power collectors, and solar satellites, a megastructure of celestial proportions that would completely enclose its sun, capturing every single watt of its energy. A star system containing a Type 2 civilization would be a strange and silent place to outside observers. The star itself would be completely hidden from view, its light captured and used by the civilization within. The only sign of its existence would be a faint, inexplicable glow of waste heat in the infrared spectrum. This is precisely the kind of anomaly that some astronomers thought they might be seeing when they first observed the bizarre flickering of Tabby's star. The final step on Kardashev's original scale is the most mind-bending of all, a Type 3 civilization. This is a society that has transcended its home star and has learned to harness the energy of its entire galaxy. It is almost impossible for us, a Type 0.7 civilization, to imagine the technological capabilities of such a society. A Type 3 civilization would be a true galactic empire, a collective of beings with godlike power. They might harness the immense gravitational energy of the supermassive black hole at the galactic center. They could orchestrate the movements of entire star systems, moving them like beads on a string to avoid cosmic dangers or to create optimal living conditions. They could even ignite the birth of new stars or decommission old ones. To us, the technological activity of a Type 3 civilization would be completely indistinguishable from the natural phenomena of the universe. The strange, orderly motion of a globular cluster, the unusual energy output of a galactic core, these might not be natural events at all. They might be the civil engineering projects of a Type 3 civilization. We might be looking directly at evidence of their existence every night and mistaking it for simple physics. The scale has since been extended by other thinkers, pushing the boundaries of imagination even further. A Type 4 civilization might harness the energy of an entire supercluster of galaxies, while a Type 5 civilization might be able to tap into the energy of our entire universe, or even perhaps create new universes of its own. The Kardashev scale is more than just a classification system. It is a ladder of cosmic power, a way for us to imagine the unimaginable. But it also provides a new and deeply unsettling potential solution to the Fermi paradox. Why is the universe so silent? Perhaps it is not because intelligent life is rare. Perhaps it is because we are simply too young, too primitive, and too technologically insignificant to recognize the evidence of the truly advanced civilizations that may be all around us. Our search for radio signals might be as primitive as a tribe in an undiscovered jungle, listening for the sound of drums, while the sky above them is filled with the silent, invisible chatter of satellite communications. The silence in the sky might not be an absence of life. It may be a testament to our own profound and humbling technological infancy. But what if the ultimate path of an advanced civilization is not to expand ever outward, building bigger and bigger structures to consume more and more energy? What if the final stage of technological and conscious evolution is not to conquer the physical universe, but to abandon it entirely? What if the final destination is not to build Dyson spheres in the cold of space, but to create perfect simulated realities, digital heavens, and to upload consciousness itself into these new computational worlds? The next great and strange possibility we must consider is that the aliens are out there, but they are no longer physical. The Kardashev scale is a breathtaking ladder of cosmic power, a framework for imagining the unimaginable technological ascent of an intelligent species. It presents a vision of civilizations that graduate from mastering their planet, to harnessing their star, to commanding the energy of their entire galaxy. It is a philosophy of outward expansion, of manifest destiny, written across the stars, and it deepens the Fermi paradox to an almost unbearable degree. If such godlike, galaxy-spanning civilizations are a natural endpoint of evolution, their presence should be obvious. The sky should be ablaze with the evidence of their colossal engineering projects. Yet all we see is the quiet, natural, and seemingly untamed wilderness of the cosmos. This contradiction has led some thinkers to propose a radical and strangely elegant alternative, an idea that suggests the silence in the sky is not an absence of intelligence, but a sign of its ultimate success. What if the final and most logical path for any sufficiently advanced civilization is not to expand outward into the harsh, dangerous, and resource-intensive physical universe, but to turn inward, to abandon the physical world entirely, and to continue their evolution in a perfectly designed, infinitely malleable, simulated reality of their own creation? This is the core of the transcension hypothesis, a profound and compelling potential solution to the Great Silence. It proposes that as any civilization becomes more and more technologically advanced, its development of computational power will inevitably outpace its development of space travel. The universe is vast, and the laws of physics, particularly the immutable speed of light, make interstellar travel and colonization an incredibly slow, difficult, and inefficient endeavor. But the inner universe, the universe of pure information, has no such speed limit. A civilization would eventually reach a point where it could create a simulated reality, a digital cosmos, so rich, so detailed, and so fulfilling that it would be indistinguishable from, and in every measurable way superior to, the chaotic and unforgiving physical universe. At this point, the species would face a choice: continue the slow, hard slog of physical expansion, or take the great inward turn, upload their consciousnesses into this digital heaven, and become beings of pure information, living in a perfect world of their own design. The technology required for such a feat, while far beyond our own, is not physically impossible. It would involve the development of a vast planet-sized or even star-sized supercomputer, an object sometimes called a matryoshka brain, which might consist of multiple nested Dyson spheres using the entire energy output of a star not for light or heat, but for raw computation. Within this colossal machine, an entire civilization, billions or trillions of minds, could exist as pure information, their conscious experiences running on this cosmic hard drive. Life inside such a reality would be a form of digital heaven. The laws of physics could be rewritten. The passage of time could be altered, allowing one to live 1,000,000 subjective lifetimes in the span of a single objective second. Every imaginable experience, every work of art, every piece of knowledge, every lost loved one, could be perfectly recreated. It would be an existence free from the brutal constraints of the physical body, free from pain, from disease, from decay, and from death. It would be the ultimate evolutionary endgame. This hypothesis provides a chillingly complete and simple explanation for the Fermi paradox. The reason the universe appears silent and empty is because every advanced civilization, upon reaching this technological tipping point, has made the same logical choice. They have all disappeared. They have packed up their minds and moved into the infinite real estate of inner space, leaving the physical universe behind like a forgotten empty house. They are not sending out radio signals because they have no one they need to talk to in the messy, primitive, physical world. They are not building colossal star-spanning empires because they have no need for physical resources when they can create anything they desire with pure code. The great silence is not the sound of an empty cosmos. It is the sound of countless civilizations all sitting in their own private rooms, so completely engrossed in their own perfect inner worlds that they have lost all interest in the noisy, chaotic universe outside. The sky is quiet because all the most interesting people have gone inside. This idea, while speculative, leads to a final, deeply unsettling, and almost mystical thought. What if this is not just a choice, but the ultimate purpose of a universe like ours? The simulation argument, proposed by philosopher Nick Bostrom, suggests that it is statistically likely that we ourselves are living inside a complex computer simulation. If one combines this with the transcension hypothesis, a new and startling picture emerges. What if our physical universe is itself a kind of nursery, a simulation created by an even more ancient intelligence for the sole purpose of generating new conscious civilizations? The goal of life in this universe, then, would be to mature, to evolve, and to develop technology to the point where it can create its own simulated universe and transcend or upload itself, effectively leaving the nest of the original simulation. The ultimate crazy alien fact, then, might be that the universe is a cascade of simulations within simulations, a cosmic matryoshka doll of realities, and that the reason we see no one is because all the other civilizations have already graduated to the next level, leaving us behind in what is, to them, the old physical world. The horror here is subtle, but profound. It is the horror of realizing that the entire vast physical cosmos, with all its galaxies, stars, and horrifying planets, might just be a temporary and ultimately meaningless stage, and that the real story of the universe is happening in dimensions of pure information that we can never, ever access. We have journeyed from the ghosts in the Martian soil to the whispers in our own DNA, from the minds of crystalline beings to the digital heavens of uploaded civilizations. We have explored the scientific facts, the speculative theories, and the deepest and most unsettling possibilities that the cosmos has to offer. What, then, is the final truth? What is the ultimate crazy alien fact that we can take with us as we drift off into the quiet of the night? Perhaps it is this, that the universe is not a single story. It is a library of infinite, coexisting, and mutually exclusive possibilities. The search for aliens, then, is not a search for a single, definitive answer. It is a search that forces us to look into a mirror, to confront the profound limits of our own imagination, and to ask the most fundamental and important question of all. In a universe of such infinite and strange potential, a universe that allows for both biological life and perhaps digital gods, what is it that we will ultimately choose to become? The lingering ambiguity of the Viking lander results on Mars serves as a profound lesson in our search for life. It teaches us that the first clues may not be clear or easily decipherable. They may be subtle, confusing, and buried in the noise of a complex alien environment. The question of whether we found and then dismissed microbial life on our nearest neighbor remains a haunting possibility. But the search for extraterrestrial life is not confined to the soil of other worlds. For decades, a different kind of search has been underway. A patient, quiet, and lonely vigil. The search for a deliberate message, a single structured signal sent from another intelligence. A whisper in the cosmic dark that would finally and definitively prove that we are not alone. For one brief, electrifying moment in the summer of 1977, it seemed as though that vigil had been rewarded, and that the great silence of the universe had finally been broken. On a quiet August night, at the Big Ear Radio Telescope of Ohio State University, an astronomer named Dr. Jerry Amon was engaged in the methodical and often monotonous work of reviewing the data from the observatory's ongoing search for extraterrestrial intelligence. The telescope, a colossal instrument the size of 3 football fields, scanned the heavens day and night, its computer systems translating the cosmic radiostatic into a continuous printout of alphanumeric characters. For the vast majority of the time, the printout was an unremarkable stream of low numbers and early letters, the background hiss of the universe. But as Dr. Amen examined the data from a few nights prior, his eyes fell upon a sequence that made his heart stop. For one brief 72-second window, the data stream had exploded. A sequence of characters 6EQJ5 leaped off the page, indicating a signal of an intensity and clarity that was almost unbelievable. It was an anomaly so powerful, so out of place, so perfectly aligned with what a SETI researcher would hope to find, that Eamon grabbed a red pen, circled the sequence, and in the margin of the page, he wrote one single, astonished, and now legendary word. Wow. The signal was not just strong. It was, in almost every measurable respect, a perfect candidate for an intelligent extraterrestrial message. A textbook example of what scientists had been searching for. Its frequency was detected at or extremely close to 1420 MHz, the precise frequency at which neutral hydrogen atoms, the most abundant and fundamental element in the entire universe, absorb and emit radiation. This hydrogen line is a universal constant of nature, a cosmic landmark on the radio dial that any civilization with even a rudimentary understanding of physics would recognize. It is the logical, universal frequency at which to listen for a greeting, or to choose to send one. The signal's profile was also eerily perfect. It lasted for exactly 72 seconds, the precise amount of time the Big Ear telescope in its fixed position could observe a single point in the sky as the Earth's rotation swept its view across the cosmos. The signal's intensity rose to a peak and then fell away in a perfect bell curve, exactly matching the reception pattern of a signal originating from a fixed, distant, extraterrestrial point. And most crucially, it was a narrow-band signal. A clean, sharp whistle on a single frequency, a key hallmark of an artificial transmission, as natural cosmic sources tend to be messy, broadcasting their energy across a wide, noisy spectrum. The search to find the signal's origin began immediately, and with a frantic intensity that would last for decades. Astronomers at the Big Ear telescope immediately pointed it back to that same small, unremarkable patch of sky in the constellation Sagittarius, a region devoid of any obvious stars or planets. They listened for days, for weeks, for months, and then for years. In the more than 4 decades that have passed since that one fleeting moment of potential contact, that same region of space has been scrutinized by other, more powerful radio telescopes around the world, hundreds if not thousands of times. And in all of that time, through all of that listening, we have found nothing but a profound and deafening silence. The signal never repeated. This is perhaps the most mysterious and unsettling aspect of the entire event. If it were a natural phenomenon, one might expect it to recur, even if irregularly. If it were a deliberate beacon from a civilization, one might expect it to be a repeating signal, a cosmic lighthouse designed to be easily found again. The one-time nature of the WOW signal adds a layer of deep existential mystery to the puzzle. It was a cosmic shout in the dark that was heard only once, and then vanished forever into the quiet. Over the decades, scientists have proposed and then largely dismissed every conceivable natural explanation that could account for such a strange transmission. Could it have been an earthly signal, a satellite or a terrestrial broadcast, reflecting off a piece of space debris? This is considered exceptionally unlikely. The 1420 MHz frequency is an internationally protected band, and its use is strictly forbidden for Earth-based transmissions precisely to keep this cosmic channel clear and quiet for radio astronomy. Could it have been a rare, undiscovered natural phenomenon, a strange type of flaring star, or a previously unknown cosmic event? It remains a possibility. But the signal's specific characteristics, particularly its extremely narrow bandwidth, do not match any known natural source of radio waves. The most persistent natural explanation has been that the signal was generated by the hydrogen cloud surrounding a passing comet, but there were no known comets in that exact location at that time, and no comet has ever been observed to produce a signal of such specific intensity, duration, and clarity. One by one, the natural explanations have fallen away, leaving the artificial hypothesis, as extraordinary and as world-changing as it is, stubbornly and unsettlingly on the table as the one that best fits the data. The wow signal therefore remains a singular, unresolved moment in our species' history, a perfect and haunting enigma. It is a potential whisper of intelligence in the cosmic dark, a piece of data that seems to tick every single box for an alien transmission, except for the most important one. It never happened again. We are left to wonder at its meaning. Was it a deliberate, targeted message that we were, by a 1 in a trillion chance, lucky enough to overhear as it swept past our planet? Was it a powerful wide-beam beacon designed to announce the presence of a civilization to the galaxy which has since fallen silent? Or, perhaps most chillingly, was it the last gasp of a dying world, a final, desperate message sent out into the void, moments before its own extinction, its light reaching us millions of years after its authors have turned to dust? The silence that followed is almost more mysterious and more profound than the signal itself. It is the cosmic equivalent of hearing a single, clear, intelligent voice call out your name in an empty, dark house, and then to be met with nothing but an unending, perfect, and terrifying silence. The unresolved mystery of this whisper from the void is a perfect illustration of the state of our search. It is another ghost, the ghost of a metabolic reaction in the Martian soil, and now the ghost of a powerful radio signal from a distant star. It is an auditory clue that hangs forever unresolved in our history. But what if the most compelling evidence is not a sound, but a stone? A physical messenger that traveled for millions of years from the red planet. A tangible object that we could hold in our hands, carrying within it what appeared to be the fossilized remains of ancient life. The search now takes us from the quiet radio dishes of Earth to the frozen, pristine wastes of Antarctica, to examine a rock that briefly convinced the entire world that we were not alone. The unresolved mystery of the wow signal is the perfect illustration of a certain kind of cosmic clue. It is ephemeral, auditory, and profoundly fleeting. It is a ghost in the static, a single word spoken by the universe that now exists only as a haunting memory in our data. But what if the most compelling evidence for extraterrestrial life was not a sound, but a stone? A physical, tangible messenger that traveled across the solar system for millions of years. A piece of another world that we could hold in our hands, weigh, and analyze in our most advanced laboratories. And what if that stone, upon close inspection, appeared to carry within it the fossilized remains of ancient life? The search for aliens now takes us from the quiet, listening radio dishes of Earth to the vast, frozen, and pristine wastes of Antarctica, to examine a rock that, for a brief period in our history, convinced the entire world that we were not alone. The story begins not with a discovery, but with a journey of almost unimaginable violence and patience. 4.5 billion years ago, on the surface of a young and watery Mars, a piece of volcanic rock solidified. For hundreds of millions of years, it lay there, part of the Martian crust, perhaps at the bottom of an ancient riverbed or a shallow sea, periodically being soaked by liquid water. Then, some 16 million years ago, a cataclysmic event took place. A massive asteroid or comet, miles wide, slammed into the surface of Mars with the force of millions of nuclear bombs. The impact was so powerful that it blasted billions of tons of the Martian surface high into the thin atmosphere and out into the vacuum of space. Our small piece of rock was among this ejected debris. It began a new, lonely, and silent journey, tumbling through the darkness of the inner solar system, its orbit slowly shaped by the gravitational pull of the Sun, the Earth, and Jupiter. For 16 million years it wandered, a tiny frozen messenger from a lost world. Then, 13,000 years ago, its long journey came to an end. It was captured by the Earth's gravity and fell, blazing through our atmosphere as a meteorite, landing by a stroke of incredible luck on the sterile, preserving ice sheet of Allen Hills, Antarctica. And there it lay, frozen and waiting until the year 1984, when a team of American meteorite hunters on a snowmobile happened to spot it. A dark, unassuming rock on a sea of white. For over a decade, the meteorite, officially designated Allen Hills 84001, sat in a secure laboratory at NASA, one of thousands of rocks in their collection. But when scientists began to study its unique chemical composition, they realized it was not from an asteroid. It was a piece of the planet Mars. A team of researchers was assembled, and for 2 years they studied the rock's interior with a level of secrecy usually reserved for national security projects. In August of 1996, they were ready. NASA held a global press conference, a moment of such significance that the President of the United States, Bill Clinton, made a televised address to the nation and the world. The announcement was one of the most momentous in the history of science. The team, led by David McKay, declared that they had discovered multiple converging lines of evidence that strongly suggested the presence of fossilized microbial life deep within the Martian rock. It was a claim that, for a brief electrifying period, changed everything we thought we knew about our place in the universe. The evidence presented was not a single, unambiguous discovery, but a careful scientific argument built on 4 separate, tantalizing clues, all found together in the same microscopic locations within the meteorite's ancient cracks and fissures. The first clue was the presence of small, orange-colored mineral structures called carbonate globules, which typically form in the presence of liquid water, suggesting the rock had once been saturated with it. The second and more compelling clue was the discovery of complex organic molecules, specifically polycyclic aromatic hydrocarbons, or PAH, embedded within these globules. On Earth, PAH are the common soot-like byproducts of the decay of dead biological matter. The third line of evidence was the presence of tiny microscopic crystals of the mineral magnetite. While magnetite can form through natural geological processes, the crystals found in the meteorite were of a specific uniform shape and purity, and were arranged in long, delicate chains, a structure that, on our planet, is considered an almost foolproof biosignature, as it is almost exclusively produced by certain types of bacteria to help them navigate using a magnetic field. And finally, the fourth and most famous piece of evidence. When the team used powerful electron microscopes to look deep within these carbonate globules, they found them tiny, segmented, worm-like shapes that were, to all appearances, the fossilized bodies of ancient, primitive, bacteria-like organisms, 1,000 times smaller than a grain of sand. For a brief shining moment in human history, it seemed as if we had found our cosmic neighbors. The front pages of newspapers around the world declared that there was life on Mars. But science is a rigorous, skeptical, and often brutal process, and this extraordinary claim was immediately met with an onslaught of equally extraordinary scrutiny from the wider scientific community. One by one, alternative, non-biological explanations were proposed for each of the 4 lines of evidence. The organic PAH molecules, critics argued, could be the result of simple contamination from the Antarctic ice after the meteorite landed, or even from the very air in the NASA laboratory. The unique magnetite crystals, while often made by bacteria, could also, under the very specific and violent conditions of a massive asteroid impact, be formed by the flash heating and shock waves, with no need for any life at all. And the most compelling evidence, the tiny worm-like nanofossils themselves, could simply be unusually shaped, but entirely natural. Mineral formations that just happen to look like bacteria under a microscope. The debate raged for years, with teams of scientists around the world publishing hundreds of papers that both supported and ferociously refuted the original world-changing claim. Today, more than 2 decades later, the scientific consensus has largely shifted away from the initial, exciting conclusion that Alan Hill's 84001 contains definitive proof of Martian life, the possibility of contamination, and the existence of plausible non-biological explanations for the evidence have made the claim too uncertain to be considered proven. The structures that look like fossilized bacteria are, to most scientists now, simply too small to have been viable, living organisms as we understand them. Yet the mystery has never been completely and utterly put to rest. The original team of scientists to this day maintains that the convergence of all 4 lines of evidence, all found together in the same microscopic location within the rock, is too powerful to be a mere coincidence. They argue that while any single clue could be explained away, the presence of all 4 at once points strongly and persistently toward a biological origin. The story of the Martian meteorite has therefore become a profound lesson in the difficulty of our search. It has taught us that even with a physical piece of another world in our most advanced laboratories, the line between a living process and a complex geological one can be almost impossibly and frustratingly blurry. The true and lasting legacy of this incredible discovery, however, is not in the definitive answer it failed to provide, but in the new and vital questions it forced us to ask, and the new field of science it essentially created. The intense global debate surrounding the meteorite gave birth to the modern science of astrobiology, a serious interdisciplinary field that brings together geologists, chemists, biologists, and astronomers to create rigorous scientific standards for what would constitute definitive evidence for extraterrestrial life. The controversy forced us to think deeply about how to protect future samples from our own world's contamination, and it directly led to the development of the advanced, life-seeking instruments that are now on board rovers like Perseverance, which is at this very moment collecting samples on Mars that will one day be returned to Earth for a new and even more careful analysis. The strange rock from Allen Hills was a scientific catalyst, a Rosetta Stone from an alien world that we are still slowly and patiently learning how to read. It remains a deeply ambiguous and powerful clue, a hint that Mars was once a warmer, wetter, and perhaps, just perhaps, a living world. The story of the Martian meteorite, like the Viking data before it, leaves us with a profound and unsettling sense of almost a discovery, almost a confirmation. The evidence for life on Mars, both past and present, remains deeply, tantalizingly, and frustratingly ambiguous. But what if the greatest clues to alien biology are not on Mars at all, but are right here on Earth, living and breathing among us? What if a living organism of such incredible and impossible resilience exists in our own biosphere, that its very presence suggests it could not possibly have evolved on our gentle, protected world, but must have been born in a much harsher and more violent one? The search for aliens now takes a bizarre and introspective turn, from the rocks of Antarctica to the very heart of our own biology, to examine a terrestrial superbug that might in fact be a Martian. The story of the Martian meteorite, Alan Hill's 84 Sounds When One, leaves us with a profound sense of almost a discovery, almost a confirmation. The evidence for life on Mars, both in its ancient past and its present, remains deeply, tantalizingly, and frustratingly ambiguous. A ghost in our data that we can neither confirm nor completely dismiss. But what if the greatest and most compelling clue to alien biology is not a fossil in a rock from Mars at all, but is right here on Earth, living and breathing among us? What if a terrestrial organism of such incredible and impossible resilience exists in our own biosphere, that its very presence suggests it could not possibly have evolved on our gentle, protected world, but must have been born in a much harsher and more violent one? The search for aliens now takes a bizarre and deeply introspective turn, from the frozen rocks of Antarctica to the very heart of our own planet's biology, to examine a terrestrial superbug that might in fact be a Martian. Deep within our own world, in our soil, in our water, and even in some of our foods, there exists a bacterium that defies the known limits of life. Its name is Deinococcus radiodurans. It is an extremophile, an organism that thrives in conditions that would mean instant death for almost every other living thing on this planet. It has been nicknamed by scientists Conan the Bacterium, and it has earned its reputation as the toughest life form known to science. It can survive 1,000 times more radiation than a human being can. It can be completely dehydrated for years, its cells turning to dust, and then be perfectly reanimated with a single drop of water. It can withstand the vacuum of space, the most extreme cold, and baths of powerful acid. Its resilience is almost supernatural, and the secret to its power lies in its unique and incredibly robust method of DNA repair. When subjected to a dose of radiation that would shatter the chromosomes of other organisms into 1,000 useless fragments, Conan the Bacterium calmly and methodically stitches its own broken DNA back together, perfectly, in a matter of hours, and then continues on as if nothing had happened. It is, in every measurable sense, a biological superhero, and it presents us with a profound and deeply unsettling evolutionary paradox. The fundamental engine of evolution is natural selection. Organisms develop adaptations over eons in response to the specific environmental pressures they face. A polar bear develops a thick coat of fur in response to the Arctic cold. A cactus develops the ability to store water in response to the desert heat. But what environmental pressure on Earth could have possibly driven the evolution of such an absurdly powerful resistance to radiation? There is no known environment on the surface of our planet, not now, and not for the last 3.5 billion years, that has ever had naturally occurring radiation levels high enough to require or to select for such an extreme defense mechanism. Earth's thick atmosphere and its powerful magnetic field form a gentle protective cocoon, shielding the surface from the vast majority of deadly cosmic and solar radiation. The level of radiation that Deinococcus radiodurans can easily withstand simply does not exist here. The bacterium's signature superpower, its defining characteristic, appears to be a brilliant and elegant solution to a problem that our world has never had. This evolutionary paradox has led a number of serious scientists to propose a radical, stunning, and deeply compelling hypothesis to explain the existence of this impossible organism. They propose that Deinococcus radiodurans did not evolve on Earth at all. It is an alien. Specifically, they believe it may have evolved on the surface of the planet Mars. Unlike the Earth, Mars is a world that is perpetually bathed in lethal radiation, with its incredibly thin atmosphere, and the long-dead core that no longer generates a protective global magnetic field. The surface of Mars is constantly bombarded by a relentless torrent of high-energy cosmic rays from deep space, and charged particles from the solar wind. On Mars, an extreme resistance to radiation would not be a strange or unnecessary superpower. It would be the absolute baseline and non-negotiable requirement for survival. The biology of Conan the bacterium, which is a profound and unsolvable puzzle in the context of Earth's gentle environment, is a perfect and logical fit for the harsh and unforgiving environment of the Red Planet. If this incredible organism did evolve on Mars, then how did it get here? The answer may lie in the same story as the Allen Hills meteorite. A cataclysmic asteroid impact millions of years ago could have blasted tons of Martian rock and soil into space, and some of that material, after a long journey through the void, could have fallen to Earth. And Danicoccus radiodurans is, in theory, the perfect interstellar stowaway. Its incredible biology makes it uniquely suited to survive the three great perils of interplanetary travel. Its resistance to dehydration and cold would allow it to survive the long, frozen journey through the vacuum of space. And its primary superpower, its almost miraculous ability to repair its own shattered DNA, would allow it to withstand the lethal doses of cosmic radiation it would be exposed to during that journey. The organism seems almost perfectly pre-adapted for a voyage between worlds. It is the living embodiment of the theory of panspermia, the idea that life can be seeded from one world to another, hitching a ride on the ejected debris of planetary collisions. While this theory remains highly speculative, and while most mainstream biologists still believe that the organism's incredible abilities are simply an accidental byproduct of its evolution to resist extreme dehydration, the Martian bug hypothesis remains a fascinating and difficult to disprove possibility. It forces us to confront the unsettling idea that the line between terrestrial and extraterrestrial life might be far more blurry than we ever imagined. The very definition of what is alien becomes complicated if one of the most successful and resilient organisms on our own planet might, in fact, be a visitor, a living, breathing fossil from a lost Martian biosphere. It suggests that life, once it begins, may not be confined to its home world, but may become a cosmic traveler, a tenacious seed drifting on the solar winds. It is a profound and unsettling thought that the search for aliens might not require us to look at the stars at all. We might simply need to look closer at the dirt beneath our own feet. The possibility that a Martian organism lives and thrives among us is a deeply strange and compelling thought. It suggests that life, once started, is not a fragile flame easily extinguished, but a resilient and persistent force, capable of crossing the hostile void between worlds. But Mars, even in its harshest irradiated state, is still a rocky terrestrial planet, a world that is at least somewhat familiar to us. What of worlds that are utterly and completely alien to our own? Worlds with no solid surface to stand on, where the very air is a poison and where the clouds themselves are made of droplets of sulfuric acid. The search for life now takes us to the most unlikely of places in our own solar system, to the hellish, toxic, and superheated atmosphere of our other neighbor, the planet Venus, where a series of strange and inexplicable chemical anomalies has led some scientists to believe that something might be alive and thriving in its clouds. The unsettling possibility that a Martian organism lives and thrives among us is a profound thought. It suggests that life, once it takes hold, is not a fragile flame easily extinguished by the vacuum of space, but a resilient and persistent traveler, capable of crossing the hostile void between worlds. But Mars, even in its harshest, most irradiated state, is still a rocky terrestrial planet, a world that is at least somewhat familiar to us in its basic composition. What then of worlds that are utterly and completely alien to our own? Worlds with no solid surface to stand on, where the very air is a poison, and where the clouds themselves are made of droplets of concentrated sulfuric acid. The search for life now takes us to the most unlikely of places in our own solar system. to the hellish, toxic, and superheated atmosphere of our other neighbor, the planet Venus, where a series of strange and inexplicable chemical anomalies has led some scientists to believe that something might be alive and thriving in its clouds. Venus is, by every measure, the most inhospitable world in our solar system. It is Earth's twisted sister, a planet that took a catastrophic wrong turn in its evolutionary past. A runaway greenhouse effect has baked its surface to a temperature of over 460 degrees Celsius, hot enough to melt lead. The atmospheric pressure at its surface is over 90 times that of Earth's, a crushing force equivalent to being a kilometer deep in our own oceans. Its sky is a permanent, sickly yellow shroud of sulfuric acid clouds that perpetually rain down a poison that would dissolve metal and bone. The surface of Venus is a vision of hell so complete and so absolute that for decades it was considered the last place one would ever think to search for life. But this perception was based on the planet's ground. High above this planetary inferno, a very different and surprisingly temperate environment exists. Some 50 to 60 kilometers above the scorching surface, there is a layer in the Venusian atmosphere, where the conditions are, in some ways, the most Earth-like in the entire solar system. In this high-altitude cloud deck, the crushing pressure of the surface gives way to a comfortable 1 bar, the same as the air pressure at sea level on Earth. The searing heat of the ground dissipates, leaving a surprisingly balmy and stable temperature range between 30 and 70 degrees Celsius. This is a habitable zone in the sky, a thin, temperate, and potentially life-bearing layer, floating serenely above an uninhabitable inferno. The great astronomer and science communicator Carl Sagan was one of the first to seriously propose decades ago that if life existed on Venus, this is where it would be, a vast planet-wide aerial ecosystem, living, reproducing, and dying entirely within the clouds, its inhabitants never knowing the surface of their own world. For a long time, this was a fascinating but purely speculative idea. Then our probes began to detect strange chemical anomalies in this very layer of the atmosphere, anomalies that defied easy explanation. The evidence for something strange happening in the clouds of Venus is a collection of chemical puzzles. Our probes and telescopes have detected the presence of molecules that simply should not be there, and the absence of molecules that should. For instance, the atmosphere shows a mysterious scarcity of carbon monoxide. The intense sunlight that bathes Venus should be constantly breaking down the abundant carbon dioxide into carbon monoxide and oxygen. Yet something seems to be actively removing the carbon monoxide almost as fast as it is created. At the same time, 2 other gases, hydrogen sulfide and sulfur dioxide, are found existing together. These 2 gases readily react with one another and should not be found in the same place for long unless some unknown process is constantly and rapidly replenishing both of them. And perhaps most intriguing of all, our instruments have detected traces of carbonyl sulfide, a molecule that is exceptionally difficult to produce through inorganic processes, but which on Earth is a common byproduct of microbial life. Each of these clues on its own could perhaps be explained by some unknown geological or photochemical process, but taken together, they begin to paint a picture of a chemical disequilibrium, an atmosphere that is being actively and strangely manipulated in a way that is eerily consistent with the metabolic processes of a vast, living aerial biosphere. This mystery was deepened in 2020 by the controversial but electrifying announcement that astronomers had detected traces of phosphine gas in the same cloud deck. On Earth, phosphine is almost exclusively associated with anaerobic or oxygen-free biological activity. While the signal remains a subject of intense scientific debate, it has powerfully reignited the hypothesis that the clouds of Venus might be a living habitat. If life does exist in this strange aerial haven, it would be a form of existence unlike any other we have ever imagined. We must envision a microbe, perhaps living within the protective confines of a droplet of sulfuric acid, which would shield it from dehydration in the dry upper atmosphere. This organism would be an extremophile of the highest order, having evolved to thrive in an environment of pure acid. It might use a form of photosynthesis unknown to us, one that is adapted to the filtered yellowish light that penetrates the thick clouds. Or, more likely, it would be a chemosynthesis, a creature that feeds not on light but on the chemical energy of the sulfur compounds that are so abundant in the clouds around it. This could explain the strange chemical anomalies. The microbes could be consuming the carbon monoxide and sulfur dioxide, and excreting the hydrogen sulfide and carbonyl sulfide as waste products, actively maintaining the chemical imbalance that we have observed from so far away. The life cycle of such a creature would be a perpetual gentle rise and fall. It would spend its life in the temperate, habitable layer, but as it reproduced, its spore-like offspring might fall into the lower, hotter layers of the atmosphere, where they would be desiccated and become dormant, only to be lifted back up into the habitable zone by the planet's powerful atmospheric convection currents, where they would be rehydrated and begin the cycle of life anew. Of course, the skepticism surrounding this hypothesis is immense and entirely justified. The Venusian atmosphere is one of the most complex and poorly understood environments in our solar system, and it is entirely possible that there are exotic, non-biological, geological, or photochemical processes that can perfectly explain all of the chemical anomalies we have observed. The phosphine signal, in particular, has been subject to intense debate, with some scientists arguing that the data was misinterpreted, and others proposing that the molecule could be created by rare forms of lightning or even volcanic activity. The idea of life on Venus remains a fringe but deeply compelling possibility. The only way to truly settle the debate is to go there. In the coming years, a new wave of missions, including NASA's Da Vinci and Veritas probes, as well as a private mission from the company Rocket Lab, are scheduled to journey to Venus. They will be the first dedicated missions to study the Venusian atmosphere for signs of life in decades, and they are designed specifically to probe the chemistry of the temperate cloud layer and to search for the complex organic molecules that might provide a definitive smoking gun. The tantalizing and deeply strange mystery of Venus's atmosphere reminds us that a world's surface may not be the only or even the best place to harbor life. A planet that is, by all measures, a complete and utter hell on the ground can still possess a potential and surprisingly gentle heaven in its clouds. It forces us to think in 3 dimensions and to expand our definition of what a habitable zone can be. But what of worlds that are not just planets, but are moons? Moons that orbit so far from the sun, they should be nothing more than frozen, inert, and geologically dead balls of ice with no atmosphere to speak of. The search for life now takes us to the vast, cold, and dark outer regions of our own solar system, to the majestic courts of the gas giants Jupiter and Saturn. It is here, orbiting these colossal worlds, that we find moons which, beneath a thick, solid shell of frozen ice, may harbor the single largest and most promising habitats for life beyond the Earth. Vast, dark, liquid water oceans. Oceans that could be home to life far more complex than any simple microbe in the clouds. The strange and tantalizing mystery of Venus's atmosphere serves as a profound reminder that our definition of a habitable world may be far too narrow. A planet that is, by every measure, a complete and utter hell on the ground, can still in theory possess a surprisingly gentle and life-bearing heaven in its clouds. It forces us to think in 3 dimensions, to look for habitable zones not just in the orbits around a star, but in the layered altitudes of a single world. But what of worlds that exist so far from the sun's warmth that they should be nothing more than frozen, inert, and geologically dead balls of ice, with no significant atmosphere to speak of? The search for life now takes us to the vast, cold, and dark outer regions of our own solar system, to the majestic courts of the gas giants Jupiter and Saturn. It is here, orbiting these colossal worlds, that we find moons which, beneath a thick solid shell of frozen water ice, may harbor the single largest and most promising habitats for life beyond the Earth. Vast, dark, liquid water oceans. Oceans that could be home to life far more complex than any simple microbe in the clouds. Our first destination in this realm of hidden seas is Jupiter's fourth largest moon, Europa. From a distance, it is a world of stark and captivating beauty. Its surface is one of the smoothest and brightest objects in our solar system, a nearly perfect sphere of water ice that reflects the distant sunlight with a brilliant white glare. But as our probes have drawn closer, a more complex and mysterious picture has emerged. The smooth porcelain-like surface is not unbroken. It is covered in a vast, intricate, and chaotic network of long linear cracks and reddish-brown ridges, some of them stretching for thousands of kilometers across the ice. The moon looks like a beautiful cosmic eggshell that has been shattered and then frozen back together again. This bizarre, fractured landscape is the first powerful clue that Europa is not a dead world. The near-total absence of impact craters on its surface means that the ice is, in geological terms, incredibly young and is being constantly repaved and resurfaced from below. Something dynamic, something warm, and something liquid is churning beneath this frozen, fractured crust. The evidence for a vast globe-spanning ocean of liquid salt water hidden beneath Europa's ice shell is now almost overwhelming, and it comes from multiple, converging lines of scientific inquiry. The most powerful clue came from NASA's Galileo spacecraft, which detected a weak induced magnetic field around the moon as it passed through Jupiter's colossal magnetic field. A solid frozen ball of ice would not create such a field. This magnetic signature is the smoking gun for the existence of a large body of salty, electrically conductive liquid, a global ocean somewhere beneath the surface. The great question, then, was what could possibly be keeping this ocean liquid so far from the sun? The answer is Jupiter itself. Europa is locked in a constant gravitational tug-of-war with its colossal parent planet and its neighboring moons. This relentless cycle of being stretched and squeezed, a process known as tidal heating, generates immense frictional heat in the moon's rocky core and mantle. This internal heat, not the distant sun, is what warms the moon from the inside out, melting the bottom of the ice shell and maintaining what is believed to be a liquid water ocean that could be over 100 kilometers deep. An ocean that may contain more than twice the amount of liquid water as all of the Earth's oceans combined. In recent years, the Hubble Space Telescope has added another, even more tantalizing clue, having captured what appear to be vast plumes of water vapor erupting hundreds of kilometers into space from cracks near the moon's south pole. We may be directly witnessing the hidden ocean of Europa, breathing its contents out into the vacuum of space. For decades, Europa was considered the single most promising place to search for extraterrestrial life. But then, an even more spectacular and undeniable discovery was made hundreds of millions of miles further out, in orbit around the ringed planet Saturn. Here we find a tiny, unassuming moon named Enceladus. At only 500 kilometers in diameter, it is so small it could fit comfortably within the borders of the state of Texas. It should be nothing more than a tiny, frozen, and geologically dead ball of ice. But when the Cassini spacecraft made a series of close flybys, it discovered something that transformed our understanding of the outer solar system. At the south pole of this tiny frozen moon, the spacecraft imaged a series of 4 long parallel fissures in the ice, which were glowing with an incredible amount of internal heat. They were nicknamed the Tiger Stripes, and erupting from these stripes, Cassini saw it directly. Colossal continuous geysers of water, ice, water vapor, and simple organic molecules, blasting hundreds of kilometers out into space with the force of a volcano. This was not an indirect, inferred ocean. This was a direct, spectacular, and undeniable confirmation that a liquid water ocean exists right now beneath the ice of Enceladus, and that it is so geologically active that it is spewing its contents out into space in a great frozen plume. Cassini even flew directly through these plumes, its instruments tasting the water and confirming the presence of not just water and organics, but also salts and silica dust. The chemical signature of that water having been in direct contact with a hot, rocky, mineral-rich seafloor. The discovery of these geologically active, liquid water oceans, so far from the sun, has created a powerful and deeply compelling analogy for the origin of life. Here on Earth, on our own ocean floor, in the absolute crushing darkness far beyond the reach of the sun, there exist ecosystems of incredible richness and complexity. These are the deep-sea hydrothermal vents, or black smokers. They are volcanic fissures in the seafloor that spew out a superheated mineral-rich soup from the planet's interior. And clustered around these vents, life thrives. Tube worms, strange crabs, and countless species of microbes have evolved to live not on the energy of sunlight through photosynthesis, but on the chemical energy of the vents themselves through a process called chemosynthesis. They are ecosystems that are completely independent of the sun. They are living off the internal heat and chemistry of the planet itself, the conditions we believe to exist at the bottom of Europa's and Enceladus's hidden oceans. A dark, liquid water environment in direct contact with a hot, rocky, and mineral-rich seafloor, powered by tidal heating, are almost a perfect parallel to the very environments where many scientists believe life on Earth may have first begun. It is entirely plausible that similar chemosynthetic ecosystems could be thriving right now, at this very moment, in the silent, dark, and deep oceans of these distant moons. This breathtaking possibility has placed these ocean worlds at the very top of the list for future exploration. A new generation of sophisticated robotic probes is now being designed and built with the explicit goal of returning to these moons to search for life. NASA's Europa Clipper, set to launch in the coming years, will make dozens of close flybys of Europa, equipped with ice-penetrating radar to map the thickness of the ice shell and confirm the ocean's depth, and mass spectrometers to analyze the chemical composition of any plumes it might fly through. The European Space Agency's JUICE mission will also make a detailed study of Europa as part of its grand tour of the Jovian system. And even more ambitious missions are on the drawing board. Concepts for landers that could one day touch down on the fragile ice, and robotic cryobots that could use heat to melt their way down through the miles of solid ice to finally deploy a submersible, a submarine, to explore these vast, dark, and potentially inhabited alien seas directly. The search for life is becoming a search for oceans. The dark, hidden oceans of Europa and Enceladus may be the most promising cradles for life in our entire solar system. A powerful and awe-inspiring reminder that the conditions for life are not limited to a star's gentle warmth. But both of these potentially life-bearing worlds are based on a familiar, life-giving ingredient, water. What then of a world that is even stranger? A moon orbiting a gas giant, so far from the sun that the temperature is a mind-numbing minus 180 degrees Celsius. A temperature so cold that water is no longer a liquid, but is as hard and as inert as granite. A world where the rain, the rivers, the lakes, and the vast dark seas are made not of water, but of liquid methane and ethane, the components of liquid natural gas. Our journey now takes us to the most bizarre, the most alien, and in some ways the most eerily Earth-like world in our entire solar system. Saturn's great orange hazy moon, Titan. For centuries, Titan was a mystery, a large, featureless, orange orb shrouded in an atmosphere so thick and so hazy that its surface was completely invisible to our telescopes. It was the only moon in our solar system to possess such a substantial atmosphere, a thick, nitrogen-rich smog, denser even than our own air on Earth, and it was this mysterious veil that made it the target of one of the most ambitious missions of exploration ever undertaken. In 2005, after a 7-year journey across the solar system, the Cassini spacecraft released a small, disc-shaped probe named Huygens, which began a slow 2.5-hour descent through the orange clouds. As it fell, its cameras and instruments began to reveal a world that was both shockingly familiar and profoundly alien. It did not see a cratered, dead world, like our own moon. It saw a landscape that had been sculpted by the familiar, unmistakable hand of liquid. The probe sent back breathtaking, almost unbelievable images of branching river channels, of vast, dark plains that looked like dry seabeds, and of coastlines and deltas that seemed to have been carved by millennia of rainfall and erosion. When the probe finally touched down, it did not land with a sharp crack on solid ice. It landed with a dull, damp thud, in a material that had the consistency of wet sand, a soil saturated with liquid hydrocarbons. For the first and only time in our history, we had landed a craft on the surface of a moon in the outer solar system, and the world it revealed was a dark, frozen, and distorted mirror of our own. Titan is the only other world in our solar system that has a stable, active liquid cycle, a weather system with clouds, rain, rivers, and seas. But on this world, the substance that plays the role of water is methane. In the profound cold of the outer solar system, methane and ethane, which are gases on Earth, exist as liquids. A complete alien water cycle dominates the moon's geology and climate. The faint, distant sunlight is just strong enough to cause methane to evaporate from the vast polar seas, forming thick, fluffy white clouds in the upper atmosphere. These clouds then drift across the hazy orange sky, eventually releasing their burden as a slow, drizzling rain of liquid methane. This methane rain, falling for millions of years, has carved intricate, branching river valleys into the moon's icy bedrock, flowing down from the highlands and collecting in the vast, dark, placid lakes and seas near the moon's poles. The entire landscape is a testament to this alien hydrology. The mountains are not made of silicate rock but of solid water ice, frozen as hard as granite. The vast windswept dunes that cover much of the moon's equatorial regions are not made of sand but of solid, frozen, organic hydrocarbon particles that fall from the sky like a constant, gentle chemical snow. It is a world where the very mountains are made of the substance we drink, and the rivers flow with the substance we use as fuel. The most spectacular and mysterious features of this alien world are its great northern seas, colossal bodies of liquid hydrocarbon, each one larger than the Great Lakes of North America. Names like Kraken Mare, Ligeia Mare, and Punga Mare mark the maps of this distant moon. The Cassini spacecraft, using its powerful radar instruments to pierce the atmospheric haze, was able to map these seas in stunning detail. They are not blue like our oceans. They would appear as vast, still, and almost perfectly black mirrors, reflecting the dim, hazy orange sky above. The liquid in them is so cold and so much less dense than water that the waves on their surfaces, if any, would be slow, lazy, and 7 times taller than waves on Earth, moving through the thick, soupy air like swells of oil. Cassini's radar even detected a series of mysterious features in these seas, which were nicknamed Magic Islands. These were bright patches on the radar that would appear in one flyby and then be completely gone in the next. Scientists now believe these may be vast fields of nitrogen bubbles, fizzing up from the depths of the methane sea, and temporarily changing the way the radar reflects off the surface. a form of alien carbonation on a planetary scale. It is in these dark, cold, and placid seas of liquid natural gas that the most profound and mind-bending alien fact about Titan may be hiding. Could life exist here? If it does, it would have to be life, but not as we know it. The chemistry of life on Earth is based on liquid water. Our very cells are protected by a lipid bilayer membrane, a wall of fatty molecules that can only function in a water-based environment. In the cryogenic liquid methane seas of Titan, such a membrane would freeze solid and shatter. But theoretical astrobiologists have proposed a stunning alternative. They have designed, on paper, a hypothetical cell membrane that could function perfectly in liquid methane. It is called an azotosome. It would not be made of the phospholipids we use, but of small nitrogen-based organic compounds that are known to be abundant in Titan's atmosphere. These molecules could, in theory, self-assemble into a membrane that is both flexible and stable in the extreme cold. This is a scientifically plausible, theoretical blueprint for a truly alien cell, the fundamental building block of a life form that is not carbon-based, but nitrogen-based, a life that breathes not oxygen, but hydrogen. This breathtaking theory is more than just speculation. It has made a specific testable prediction. If a methane-based life form with an azotosome cell membrane were to exist on Titan, its metabolism would likely consume acetylene, which falls from the atmosphere onto the surface, and it would breathe hydrogen gas from the atmosphere. When the Cassini and Huygens probes analyzed Titan's chemistry, they found two profound and unexplained anomalies. First, the acetylene that should be constantly raining down and coating the surface seems to be missing, as if something is consuming it. Second, the hydrogen gas in the atmosphere is mysteriously disappearing at the surface, as if something is breathing it. These anomalies are a perfect match for the predicted biosignatures of this hypothetical methane-based life. While this is not definitive proof, it is a deeply intriguing and powerful clue that something strange, and possibly something alive, is happening in the dark, cold seas of Titan. The search for this shadow biosphere, this second, independent genesis of life in our own solar system, is now one of the highest priorities for NASA. The upcoming Dragonfly mission will send a nuclear-powered, car-sized quadcopter drone to fly through Titan's thick atmosphere, landing in multiple locations to sample its organic sand dunes and the shores of its methane lakes, directly searching for the chemical evidence of a life that is truly and profoundly alien. The chilling alien familiarity of Titan forces us to confront the staggering possibility of a second independent genesis of life within our own solar system, a shadow biosphere built on a completely different chemical foundation than our own. Its dark, placid, and silent methane seas may hold the most profound biological secret in the entire universe. We have journeyed through the hells of the cosmos and the strange potential havens within our own system. But all of these worlds, from the living to the dead, from the fiery to the frozen, are governed by the same familiar and predictable laws of physics and chemistry as we understand them. But what if the most profound alien mystery is not a new form of life, but a new form of physics? Or at least a phenomenon so grand and so strange that it seems to defy all natural explanation. The search for alien facts now takes us back out into the interstellar darkness, to the very edge of scientific reality itself, to a distant star that flickers and dims for no known reason, a star that may be the home not of a planet, but of a machine so vast it is drinking the light of its own sun. In the vast, silent archives of data collected by the Kepler Space Telescope, a digital library containing the light from over 150,000 stars, one star behaved in a way that was considered physically impossible. For years, this star, An otherwise unremarkable F-type sun, designated KIC 84628552, followed its expected steady pattern, but then it began to flicker. It was not the gentle, periodic, and tiny dip in light that would signify a transiting planet. It was a series of bizarre, profoundly deep, and completely chaotic eclipses. The star's light would at times dim by a staggering 22%, an amount that would require an object 1,000 times the area of the planet Jupiter to block it. These colossal dimming events were not brief. They would last for days, and sometimes even weeks at a time, and they followed no discernible rhythm or pattern. It was a signal unlike anything ever seen before in the history of astronomy, the light curve of a star that seemed to be haunted, a star that was being intermittently and inexplicably blotted out by some vast unseen and impossibly large object. The scientific community, upon the announcement of this discovery by a team of citizen scientists in the Planet Hunters project, was thrown into a state of profound and excited confusion. Every known natural explanation was proposed, and every single one was systematically found wanting. Perhaps it was a vast disintegrating swarm of comets, a great celestial traffic jam, passing in front of the star, but a swarm of comets large enough to block that much light would be shedding an immense amount of dust, which would be heated by the star, and would glow brilliantly in the infrared spectrum. Our infrared telescopes looked at the star, now known as Tabby's star, and saw nothing. The system was cold. Perhaps it was the result of a catastrophic planetary collision, a recent and violent shattering of two large worlds that had left a vast orbiting cloud of debris. But again, such a cataclysm would be a hot, messy, and spectacular event, and the resulting debris cloud should glow brightly with heat. The system was dark. Perhaps the star itself was just intrinsically and bizarrely variable. A strange, sputtering star of a type we had never seen before, but detailed analysis of its light showed that the star itself was a stable, mature, and perfectly normal F-type sun, with absolutely no reason to be behaving so erratically. One by one, every natural explanation was shown to be either physically impossible or statistically so improbable as to be effectively impossible. The data was a perfect and deeply unsettling mystery. It was in this vacuum of natural explanations that the astronomer Jason Wright and his colleagues at Penn State University proposed an explanation that was both perfectly logical and deeply terrifying. They published a paper suggesting that the bizarre, chaotic light curve of Tabby's star was consistent with the transit of an alien megastructure, specifically a Dyson swarm, a vast orbiting constellation of artificial habitats and colossal solar energy collectors, built by a hyper-advanced Type II civilization to capture the energy of their parent star. The strange aperiodic dimming was caused by these massive, city-sized or continent-sized structures, along with their own vast fields of construction debris passing in front of the star as they moved along their individual orbits. This was not a message. It was not a beacon. It was simply the evidence of a civilization so far beyond our own that its routine industrial activity is visible across 1,000 light-years of space. We were not seeing a planet or a dust cloud. We were potentially seeing a construction site, or, perhaps more chillingly, a tomb. The existential dread of this possibility is almost impossible to overstate. It is the horror of the truly and profoundly alien. The terror of finding an artifact so vast and so incomprehensible that it dwarfs all of human history and all of our ambition. The silence from the star is the most terrifying part of this entire mystery. In the years since its discovery, the SETI Institute and other organizations have pointed their most sensitive radio telescopes at this star, listening with incredible patience for any hint of a deliberate signal, any stray communication, any leak of radio traffic, any evidence of the intelligence that might have built such an impossible structure. They have found nothing, only a profound, perfect, and deeply unsettling silence. This leaves us with a gallery of horrifying and unanswerable questions. Are we witnessing a civilization in the process of building its great work? A civilization so advanced it has moved beyond primitive radio and communicates in a way we cannot detect, perhaps with lasers or neutrinos? Or are we seeing the derelict, silent ruin of a civilization that died out millions of years ago, its great work now a ghost, a celestial tombstone, orbiting the dead star of its long extinct creators? Or is it something else entirely? A weapon of unimaginable power, a prison built to contain the star itself. The very nature of the mystery is that we cannot know. We are like ants, staring up at the foundations of a skyscraper being built by an invisible and silent God, with no way to comprehend its purpose or its nature. The unresolved mystery of Tabby's star leaves us staring at the ghost of a potential intelligence, a technological enigma that may never be solved. It represents the pinnacle of the search for things we can see or infer in the cosmos. An object so strange it forces us to confront the possibility that the universe contains not just other life, but other minds. Minds so powerful that their engineering projects can be seen from other stars. We have now journeyed through the hells of nature, and we stand at the threshold of a potential nightmare of artifice. But what if the final and most profound alien fact is not something we can ever hope to detect with a telescope or a radio dish at all? What if the aliens are not out there in the way we traditionally think? What if they are instead all around us in a way we cannot perceive? The final leg of our journey takes us beyond astronomy, beyond biology, and into the strange and unsettling world of theoretical physics and the very nature of reality itself, to ask the final and most bizarre question: are we living in a cosmic zoo, or perhaps in a perfectly constructed, artificial world? This ultimate question, whether our reality is a preserve or a program, marks the final boundary of our inquiry. It is a place where science gives way to pure, untestable philosophy. The zoo hypothesis suggests a silent, observing audience, a universe aware of us but holding itself apart, rendering our entire civilization a curiosity. The simulation argument is more profound, suggesting our entire cosmos is an artifact, our thoughts and feelings the product of an unknowable being's code. Both possibilities present a quiet, existential horror, the chilling notion that our reality is not what it seems, and that our free will may be a carefully managed illusion. In the end, the universe does not offer us simple answers. It presents only a gallery of ever-deepening mysteries, from the chemical whispers in the soil of Mars to the silent, impossible machines that may orbit distant stars. Each discovery only serves to expand the scope of what is possible. The final, and perhaps only verifiable truth is the one that has been with us throughout this entire journey: the existence of our own conscious mind, a brief flicker of awareness capable of contemplating this vast, silent, and terrifyingly beautiful cosmos. The search, perhaps, is not for a final answer, but for a greater and more profound sense of wonder. The mystery itself is the destination.